problem. All right, so 21 from last night's homework. And a lot of you didn't do it because you couldn't see it. So it asked you to write a general linear equation for the line 52 points. So first thing we need is change in y over change in x. Am I skipping too many steps for anybody? Yeah, okay. All right, I'm going to do, y'all remember point slope form? In case you don't, y minus y1 equals slope. It's still laggy, but it's better than yesterday. X minus x. Yes. 21. So now I have y minus 0 is just y. I'm going to use that 0, 0 equals slope. Won't do this today. Yeah, everybody could. I tried to scan them all in, but anything else from your homework last night? 33 and 36.
So it was just y over.
That was it, yeah.
Oh, I got
It was just a line.
41.
You could have.
Y equals 3 over 2.
Okay, somebody said 33 and then do 41, Mary Margaret. All right. About what? 9. Number 9, the directions. Right vertical line and P is 3, 2. So you want a horizontal line, and so a horizontal line is in the form y equals. So that's just y equals 2. And a vertical line would just be x equals. Yeah. 33, yes, I think. 36 was pretty close to the same thing. It asked you for, no, not 36, 33. Sorry. 33 said through the point negative. Oh, I don't like this. I'm just going to have to write slow. Negative 4, and the line, the equation of the line is x equals 5. So it's a vertical line. So if you want a parallel line, right? If you think about a particular line parallel, if you think about okay, let me start over. If you think about vertical line, any other vertical line is going to be parallel to that vertical line, right? So if I want through this point, then x equals negative 2 would be parallel. And then perpendicular, if it's a perfectly vertical line, any perfectly horizontal line will be good to it, right? So y equals 4 would be perpendicular. Gotcha. Instead of that being the equation of the actual line. Okay, so clearly it's even going to let me, okay. Y equals 4. I'm not a fan of a lot of the way people work. What? I heard. What? Yeah, type it in the chat here, Margaret. The what? You gotta reset your password. Record again. 24. We've got negative 2, 1, and 2, negative 2. Define slope first. So the slope is the change in y. So 1 minus negative 2 is
Negative,
1 minus negative 2,
it's,
3. And then negative 2 minus 2, negative 4. All right, so point slope form, y minus 1 equals, does it matter which point you use in point slope form? Nope. Woo. If it does not specify a form in which to be, oh, it does, it says general.
There she
Ugh.
is. There she is.
If you want to put it in standard form, you can. I'm not going to require that you put it, but just be able to recognize. I mean, I hope we can all manipulate that at this point to put the x and the y together on the same side and the constant on the side by itself. That's the only difference. That was why. What else? Anybody? Going
Oh, wait, you don't have
once.
to solve this?
Dog it. And now I'm going to add this 1 to this side. So it's a 2 over 2, which would be negative 1/2. Nobody's getting bogged down in those fractions, are they? Okay.
Bogged down.
So technically this, what'd she say? I need an interpreter, please.
So I'm gonna completely skip 24. I went from 21 to 27 because I can't count.
No, it's not, because you couldn't see the problem, but it's the same thing.
Oh, okay.
All right, other questions about your homework?
36, 37, 41.
36?
37. 37.
We can do very well now. All right, 36 and 37. 36. A table of values. This you want it in slope-intercept form. Oh, no, you just have to find M and B. So slope-intercept form. All right, so this is a big thing in calculus. We have function notation now. And you write, it's a good thing to start writing it this way, because when we get into rate of change, there's going to be a lot of this where you see it plug a function this way. And we'll have bigger, more scarier things inside that F like that. So if you can just get used to seeing it, and just know that that's the output y. So negative 1, and then I'll do 4 negative. First, so the slope, right, is your change in y. Negative or minus negative 1 is, and then 4 minus 2. 2. And then if I want the y-intercept, which is b, so I can pick a point, I'll do that first one, negative 1. Negative.
The browser crashed.
It was not compatible with my computer. It's on the way, going back to on after school. I ordered another one last night. They better.
Wait, can you just look on the right side and see what it goes up by to get B?
That would be your slope going up. You're talking about you get rho? B is your y-intercept. This is where it's the y-axis. You're front and center on that camera now, so please don't make any obscene gestures while reporting.
I just want to look at this. Where is it? It's 36.
So it would be negative 3 plus b. So what is b? B is
2.
dose. It didn't even add the equation just for the m and the b.
So wait.
37? Was it? All right, A is... Uh-oh, are y'all still there? I just heard a...
I'm back at it. My mic keeps going in and out. So
Same, Glenn. B is 4. Oh, I like this problem. Yeah, but they said they could hear without it than with it. All right, 4y, and then it says that your slope, I'm sorry I have to write so slow, y'all, is negative 2/3. So it says find the value of x or y for which the line through AB has the given slope. So what you want to do, we know that slope, which is m, so m equals change in y, so 3 minus y over -2, 2 minus 4. Y'all good with that?
Wait.
It doesn't matter when
What
you can start with the other. Say it again, Mary Margaret.
What equation is that again, like, indicate what?
M is change in y over change x. So a lot of you are asking why we didn't start with y2, but I could have flipped and let AB and BBA and still find the slope between them. So what I'm getting at is it doesn't matter which y you start with as long as you start with that same x on the bottom. Because what you're looking for is the change in it, where it goes up or how it goes down. So as long as you start with the same one either way, it doesn't matter. All right, so I have -2/3 equals 3 minus y over -6. How do you solve a proportion like this? Cross multiply. You're exactly right, Dayton. All right, so -2 times 6 is 12. Don't forget to distribute here because we have to multiply that entire numerator there to the denominator. So I get 9 minus 3y. So I get 3 equals -3y. So y is what? -1. But you got it, that's fine.
I just multiplied that by the -2/3 by 2 and then set the top.
You got the fractions to go away. Some of you may have gotten common denominators too. No. Okay. 41. For what that this other like that? Why don't y'all like this? It makes you think a little bit. 2x plus ky equals 3, and x plus y equals 1. What value of k would make the two lines parallel? So parallel lines we know have the same what? Slope. So essentially what I do is find the slope of each line. So solve it in terms of y for both of them is what that's how I'd approach it first. So this one I would move the x over, but that's still, -2 is not my slope there because that y still got a k hooked to it. So what do I need to do? Divide by k on both sides. Okay. And so this k would get divided into both of those, so my equation would actually be -2k's x plus 3k's. And this one would be y equals, I'm going to move the x over. How do I make sure they're parallel? What should I do? Set them equal to other same slope. -2 over k should equal -1. What does k equal? What do I need to divide -2 to get -1? 2. Yes, 2. That's for parallel. That might be because the right answer was written right beside it because I accidentally wrote. Oh, okay.
I just looked at
Oh,
it.
I got you.
Because it looks like Khan Academy. And I was like, oh, it's
Perpendicular is a little bit harder. What should I do?
you should set it equal to.
I need this times this to equal what? When you multiply the slopes of perpendicular lines, what? And you may not have done it this way if you didn't. -1. So that would be 2 over k equal -1. So what does k equal? -2. Does that make sense? A little bit easier for me to apply that than it is to set it up and think about negative reciprocals and all. Everybody good? Speak now, forever hold your peace. Okay, forever hold your peace.
I can't read that.
All right,
I can't read that.
let's talk about everybody's favorite. Let's let that be first. I know I drilled domain and range in algebra. That's been a long time ago for
I
y'all.
think that's the only thing I do.
Good. You go ahead. I'm pretty loud. It doesn't bother me.
Y'all better draw perfect graph.
No.
All right.
Hit it and it
How
did
far it
nothing.
can go.
Okay, algebra 1, definitely. Okay. What are you describing, James?
The x-axis.
The x, all the x values that the graph can take on, okay? How about range? Up. Okay. Listen, but that's okay, because I mean, if you want to end it. Now remember, we can do domain algebraically or graphically, right? Algebraically, tell me domain, some things that I'm looking for. What restricts domain? Okay, but think algebraic like the equation. What in a, okay, so, well, something causes inequalities. There's two big areas that happen that restrict domain outside of trig functions. Fraction, because bottoms can't be 0, right? That gives us holes or asymptotes, right?
Like raising it to
Yes, but what kind of power?
Where?
Close, flip that around.
inverse
Square root, radicals, right? Because I can't have, once I get a negative under that goal, I start getting into imaginary territory, right? So I can't have that. So those are algebraically, I'm thinking denominators, denominators that can't be 0, and I'm thinking radicals that need to be greater than or equal to, right? Those are my two big domain restrictions when I'm talking algebraically about finding domain. And of course, whenever you get into your sine, your cosine, your tangent functions, and all the other inverse trig functions and everything, you've got all your asymptotes and your restrictions. But outside of that, when I'm looking, do y'all remember this? Am I talking too fast? Okay. All right. So let's look at an example. Let's graph it on the calculator. Let's talk about domain and range and what happens. I'm also going to show you another way that calculus describes domain and range. A lot of times we've done interval notation. I know I drilled interval notation. I think Ms. Twitty drilled interval notation. I'll show you set builder notation also that you've probably seen. You just didn't know what it was called. All right, let's do this is actually on your sheet as well. I'm pretty sure it should be, it's J. Okay, which is part of your homework today. If you want to put it in there, you can as well. This is a parent function. What parent function is this? Reciprocal function. This is reciprocal function. All right, so here we do have a calculator. So let's graph it in case you have forgotten. What do you notice before I graph it is going to happen domain-wise? X can't be
negative or
0 this time.
Oh, 0.
Right? Because it's that fraction. Bottom can't be 0 or it's going to undefine my function, which should put me a vertical asymptote on the x-axis. Does everybody remember that? Y'all sure? I don't want to be talking too much and you don't remember from pre-cal or you don't remember. Everybody's good, right? Yeah. Guys, are y'all good? Okay. All right, let's graph. Make sure that happens. And it does. Okay. So this graph looks like, also has a horizontal asymptote, nice little horizontal asymptote. I'll just put 2 points in here so you can see. 1, 1, and maybe 2, 1/2. It hugs on both sides. Same here. 1, -1. Anybody have trouble with this graph other than me whose computer is glitching? I just plugged in -1 and -2. So -1, -1, and then 2, -1/2. What's the domain here? Union, that's right.
Zero.
That's exactly right. So, set builder notation, this could come up multiple choice calculus exam, so I want to make sure I show you. So, set builder notation is a little bit different in that it tells you, it says, hey, I'm going to describe X. When looking at X, so do a line here, when looking at X, X can be everything except 0. A really easy form to see and recognize what it is it's doing. But it's just telling you the variable to look at to start with and then what that variable is doing. It's not 0. There are no other restrictions on that.
Wait, so that line, if you have X, then you have line goes down.
That defines the variable to start with, and then after that.
So I want you to write back to the name and say directions.
On the back side. That's part of the homework. We're doing part of it together, though. How about the range? Negative infinity. Oh, no. There's a, same thing. There's another, that's right. Set builder notation would look exactly the same way. But it would be a Y instead of an X, and it cannot be 0. Y'all seem to be pretty good on domain range, yes?
I don't remember doing the things under the, you said set something notation.
That's the first time you've seen it? So you can describe what it leaves out. If it was something like, have y'all already have that screen? Okay. If it was something like, let's take the square root function.
I need you to go back.
I'm sorry.
You're ready to finish.
Okay. I hope that's Coach Powell yells at us. Yay! What function is this? Square root function, right? Just basic square root function. I probably could have been a little more precise with it, but whatever. Hey, he's ready for y'all. Donovan, go. What's the domain? 0. So it's bracket 0 to infinity, right? Because it includes 0. In set builder notation, this is going to look, I'm talking about X. This is the square root function. Square root. Sorry. I wasn't going to a whole one, but yes. I'm sorry, y'all. I was really just jotting down a quick example to show what the set builder notation looked like. But y'all have been ingrained in these perfect graphs, so that's okay. That's great, though. Yes, that's 1, 1. All right, so in terms of X, X has got to be greater than or equal to 0. See what set builder notation is doing? It's basically using the inequalities or the way you used to do inequalities years ago. But putting it in brackets. Everybody good? A lot of it, yes. Same thing for range. Range is exactly the same here. It is from 0 to infinity. Or if you want to put it in set builder notation, it will look this way. Right now, I'm not going to specify to everyone you're most comfortable with right now. No, you won't do both. I was just using it as an example to show you. Oh dear, James.
That's a no brainer. How do you do that? Secret spelling? No, wait,
Tell them, Dan.
Tell him, James.
Hey, James, here.
Throw you back in. Let's look at zeros for a second. Tell me, what are zeros of a function? It's where it crosses the x-axis, right? Their x-intercepts essentially is what they are. So I can find them two ways. Graphically, algebraically. How do you find them, next? How do you find them algebraically?
Plug in, 0 for x.
Okay, you put y as 0 and you solve for x. And then you're right, Kiana, if it's a quadratic, you might have to use quadratic formula, you might factor and solve. But what it looks like this.
The bottom is 0.
You're right. You're right, Kiana. What?
You said you give up and cry.
No, you don't, Donovan. You don't give up and cry. Kiana, what might me have said? You set the bottom to 0. And I said, you're right, but I didn't hear you say that. Okay, guys, do not give up and cry. You can square root it. No, don't cry, don't cry. All right, so when we find the zeros, we set the equation equal to 0. Essentially, we're in y 0. Yes. Oh. Because every intercept means y is 0, and every y-intercept means x is 0. So if we put a 0 in for that y and solve, but since this is a fraction, the top is never going to be 0, right? Right? The bottom is going to make it undefined, and there's no way it could be 0, because if you think out for minus x squared equaling 0, it's not going to work. We're going to be undefined. So we have, you're right, Corbin, no x-intercepts for this. And so you can justify this graphically. This would be a calculator problem, by the way. 1 over the square root, yuck, of 4 minus x squared.
Wouldn't it be negative 4?
Yes, sorry. Okay, but notice here there are no x-intercepts at all. So when because what's going to happen here, and you could, but because, come on, right? Because this is happening in the bottom, if you think back to pre-cal when you talked about holes and asymptotes, that's going to be undefined points, so they're going to be asymptotes the graph can't actually cross over the x-axis there.
If you're finding the x-intercept, make the y 0 and you solve, right?
Right.
So if that y is 0, it's 0, 0, 1, 0, 1. It's not going to work.
This is never going to be 0. We can set, 1's never going to be 0.
Yes.
So the fraction's never going to equal 0 no matter what I plug in, right? I can make the bottom be 0, but by making the bottom 0, I've undefined the function, and there's asymptotes. So if you look, there are actually asymptotes at 2 and negative 2. Do you remember what causes a hole?
Yeah, it's come on, Corey, you got it.
You can do it, you can do it.
Isn't it when there's an x on the bottom and the top?
They cancel each other out. As functions written, it would cause the bottom to be 0. Maybe a factor set equal to 0 or an x equal to 0, but fully factored out and simplified, they cancel each other out, so it puts a hole in the graph. Y'all remember that? Thank you, Coach Collins. Okay, we'll talk more about that later. I was just seeing if y'all remembered. Just testing you.
So,
It's okay.
whenever we're doing these, whenever you're talking about the zeros, you just set right.
Yes. No, because we don't really do too much y-intercepts. We're just looking at the x-intercepts. The zeros are really important there. All right, so the bell is fixing to ring. It's actually going to look like this. Then this is 2 and -2, so it's not going to cross over. Oh, the y-axis. Yes, got it. Yes. I'm thinking that there's a y-intercept. Yes, I'm sorry.
Y-intercept, put 0
It's there, right.
for X.
Right. But remember, our critical points are our zeros, not such y-intercepts all the time. I mean, it's good to know them, but they're not critical. Yeah. All right, so listen, your homework is on Classroom. I'm going to have to adjust it. It's some out of the book, and it's on here. There are specific functions listed that you will do on the front. You will flip it out and do the corresponding on the back. You're just going to do domain, range, and zeros because we didn't get to symmetry today. It's symmetry tomorrow with all the rest of them, but go ahead and get those done just for those and the problems in the book. It's not as much as it looks like because it's only a few, but hang on to this, okay?
You're approving Classroom, right?
It's already there. Thank you, guys. I'm sorry I didn't make it through everything, but it was smoother today, right? It was smoother. Okay.